In this video, we will tell you about a unique feature of VEGA application, filtering of foreign objects when creating DTM or TIN network from point cloud. Foreign objects can be cars, trees, poles, and other things that are not surfaces. What makes VEGA unique is that it does not require pre-processing of the point cloud and other software, which is called grounding or classification. You simply insert the point cloud into an AutoCAD drawing as it is, without pre-cleaning, run the VEGA command, and create an accurate surface while filtering out unwanted objects. Please watch this video to the end, as there are different ways to obtain the result we are happy with. You will be able to choose the one that suits your problem. VEGA is very user-friendly, and you can set or change all the parameters. We will look at 3 examples of filtering methods. The first example is a surface with many trees. This is the point cloud. This is the surface of the Earth created by the VEGA application. The second example is an example of a car park with a large number of cars. The surface of the car park is on a slope, and it is an Earth surface. This is a point cloud. This is the surface of the Earth created by the VEGA application. The third example is a surface in the desert with metal constructions on it. We will get a clean surface with no constructions. This is the point cloud. This is the surface of the Earth created by the VEGA application. Let's get started. First example. We will look at the process of filtering trees on a surface with a slope. If we look at this surface from the side, we can see that we have a slope and trees. In this example, the slope is in one direction, but you can also do this on curved surfaces, which we'll talk about in other examples. Let's see what happens if we don't use any filters. We will use the command create mesh solids blocks points by point cloud. Using its basic parameters can be seen in a separate video, the link to which can be found in the comments below this video. We select point cloud and run the command without filtering. We work in the world coordinate system. We create a mesh that will consist of 3D face objects. You can create other objects: solid, point, block, contour line, polyline, civil surfaces. We will examine the surface from below. Approximate missing points on the point cloud. Set the distance between mesh points to 1.5 meters and a small tolerance. VEGA will look for the closest point to the calculated point that is within the tolerance and will build the mesh based on these points. We will not change anything else. Select Window. The command sets the top view. Select Area. Let's look at the resulting surface from the side and make the point cloud invisible. We have an uneven surface, which is understandable because we have not used any parameters for filtering objects. Let's make it look realistic. All these triangles are trees that have not been filtered. Now let's change a few parameters and see how the result of the command changes. First, we'll change just one parameter: tolerance. We set it to 3 meters. VEGA will look for points within a 3-meter radius of the calculated point that are as close to the surface as possible. We've only changed one parameter. Let's see what the result is. As you can see, the number of pyramids that have appeared in place of trees has become much smaller. Now we will use other parameters and do a more precise filtering. Let's go back to the original situation and take a closer look at our surface. Find the highest point on the sloped surface using the VEGA tool called Dynamic Pointer. There is also a separate tutorial video dedicated to its use. This tool shows us the coordinates of a point on the surface. I am now on the ground, and I am now on a tree. To find the highest point on the surface, we're going to look at our point cloud from the side. This is most likely the highest point. It's 807.66. Let's run the Create Mesh command. Select the surface and proceed. The parameters that we're not going to change are covered in the Basic Parameters video. Now we are going to use additional filtering. Height filters, which determine which points to consider when creating a mesh, and which to filter based on their z-coordinate. By default, we have the minimum and maximum values of the point cloud height. There is also an additional filter that filters out nearby points. For example, if the height difference between two close points is less than 10 centimeters, only one point is taken. We will not use it now. The only parameter we have changed is the maximum height. We turn off the point cloud, look from the side, and see a smooth surface, except for a few places. Could be bushes. We separate the triangles by the slope angle of the triangles, and immediately see places with a high slope. We're going to turn off all the layers that are flat enough. I'll delete the triangles we're not interested in. We have a mesh with gaps. Now we are going to run the Create Mesh by Objects command to create a new mesh without gaps from existing objects. These can be 3D faces, points, blocks, lines, or polylines. We will create the mesh in the world coordinate system. In the same command, we can create a text file with coordinates, but we will not do it now. We will not change the key boundary of the existing 3D surface. But if the boundaries of the mesh are concave, or we don't want to close the gaps, we can use these parameters. We will not be round the coordinates. The accuracy is 0. We get a new surface. We can remove unnecessary triangles in another way. We do a separation by slope and look from the top. We see the peaks. We use the Erase object by Brush command. It works similarly to the Brush command in Photoshop. By pressing the plus or minus key, we either reduce the radius of the brush, we erase problematic objects. We create a mesh. Let's go back to the original state and look at another way of filtering. As you have noticed, we are moving from simple problems to more complex ones, using more and more of VEGA's capabilities and showing its different filtering algorithms. And, as we said at the beginning, you can choose the algorithm you are most comfortable with. Now we will look at the filtering algorithm using key points. The parameters used in this command are similar to those used in the previous command. We are not going to change anything in the parameters. A new window will appear where we can select the block type. We choose the type of block arrow. We set the scale 0.2. The height when inserting the block is written to an attribute, but we have no height attributes in this block. Let's take a side view of what we have. We'll do a layer and color separation, taking into account the height of the point position. Using this command was also covered in detail in the video we talked about earlier. We've separated the objects into 20 groups. Now it is very accurate to see that most of the points are on the surface. We make our point cloud invisible. That where we had trees, there are no points. Now we have the ability to actually point each future vertex of the mesh. We remove the points that could be artifacts. It's not a problem if we remove some extra points. We have a good network density, and skipping a few points will not affect anything. In this way, we finally clean up the surface. In this example, where the surface is not very curved, there is another, faster way to remove unnecessary points. Let's call it mowing the grass. Since our surface is sloped, we set the side view and see everything we need to see. Using the erase command with the fence parameter, we draw a line across the protruding tails of our arrows and erase the unnecessary points. We look at the surface again. We can see that our points are on the surface. If there are any points that we want to add manually, so that we have full control, the program gives us that option. To add points, we will use the VEGA command called Insert VEGA Blocks on Point Cloud. This is the same window we just saw, and we're just going to manually add points where we want to look. Let's say there are obviously no points here, and we want to have points here that define the surface. Let's add a point here and here and here. The convenience of this tool is that I can see the elevation where I'm inserting the point. I'm on an earth surface right now, and here I'm on a tree. You can see that the elevation here is 809, and here it's 806. I always have the coordinate of the surface that the point is on. I want to add points, here points, here points, here points. These points are what will define our surface. We want to make sure that we don't have any unnecessary artifacts. Right here, we're going to have a fairly large triangle. We will create a mesh using the Create Mesh command. We've got a very smooth surface. Let's see how it looks in realistic. The surface can be smooth. This is convenient for modeling, but of course it will be an approximation. By default, VEGA does not approximate. Now I will show you what it means. Turn on the point cloud, switch to wireframe mode, and approach any of the points. We remove all triangles for which it is one of the vertices and see that all these vertices were on one of the points belonging to the point cloud. This means that VEGA is working with a zero approximation, and the accuracy of the surface depends solely on the accuracy of your point cloud only. Second example. We will now look at a more complex example. In it, the main foreign objects are cars. But the main difficulty is that this is a surface that is curved in all directions. That is, if in the previous example we were able to look from the side, it was about an angle of inclination. Here there is no such angle. The surface is curved from all sides and is quite difficult to process. Now we're going to use a different method to clean up the surface. We're going to use a different algorithm that comes in handy here. First of all, let's clean the surface roughly. By the way, we could have done in the previous example as well. We will remove, without too much effort, unnecessary trees that are sure to be in our way. To do this, we will use the crop function. There are many different tools in the VEGA application that allow us to make different crops and slices. We remove all the points that are left at the bottom. We've got our surface with the trees trimmed a little bit. You can trim it even more to make it more comfortable. It is not important and does not affect the final result, but it makes it possible to see our surface better. So we have a surface with cars on it, which is curved in all directions, and we need to get a clean surface of this parking lot by filtering out the cars. Let's use roughly the same algorithm we used last time. Let's run the Create Mesh command, select Point Cloud and Mesh, and set the same distance. But let's make the tolerance values high right away, so that as much as possible is filtered out. Let's select Windows. Let's take a look at what we have. Now we're going to do a color and layer separation, using the 3D face angle as a parameter. We can close the layers that define the surface for sure. This is where some hills begin to appear. We can erase these triangles, as we did in the last example, and recreate the mesh using the Create Mesh command. Let's do the color separation again. There are still slopes on the surface. We can use the same brush tool, and gradually deleting unnecessary points in this way, we will get the surface. Now let's see how we can use key points in this case. Everything is the same. We do not change anything. Of course, it will be more difficult to mow the grass, as we did last time. We'll hide the point cloud and separate the key points by height. And if we look from the side, we will immediately see some points that are definitely in unnecessary places. In this case, to remove these objects, we will turn off the layers one by one so that we can find the unnecessary points. From the bottom to the top, I remove the points that are artifacts. In this way, we would gradually make a precise cleaning of the surface. If we look closer, we can see that the vast majority of the points found by the VEGA program are on the ground surface. We could reduce the size of the blocks to make them easier to see. Of course, we could create them in smaller sizes all at once. I use the Block Manager command, Resize Blocks. I select all the blocks. We can press the minus key to make them smaller, or the plus key to make them bigger. Or we can press the M key, select Multiply, and reduce them by 0.75. We've minimized those points. And now if we look at our surface from above, we can see that the vast majority of the points are on the ground. If we had set a larger tolerance, this point would not be here. Now I will show you another algorithm that can be used in this case. We will select key points and change one parameter. We're going to make the distance between the points 5 meters. And we're also going to increase the tolerance. We're going to get a very rough surface detail. Let's scale down the blocks right away so we can work more easily. Let's set the value to 0.2. If we now change the transparency of the point cloud, we can see that almost all the points are on the ground. We've got a rough partition of the ground surface that doesn't take into account the fine features of the surface. We can add the points that we are interested in. Let's add points like we did in the previous example. Let's bring back the transparency and make this point cloud invisible for a while. We create a mesh from these key points using the Create Mesh by Objects command. Let's see what we get. We've got a pretty plain ground surface. We return to the key points using the Undo command and make our point cloud visible again. We run the Create Mesh command. I'm going to set a good accuracy for the points. 1.5 meters. I change the tolerance. In this case, you can set it to 0.5 meter. We're interested in this parameter. If I set it to 15 centimeters, it means that the points that are above or below 15 centimeters from the ground surface that we have defined with our key points will be filtered out. I have an additional question now. Select the objects that will be the key objects. These can be blocks, polylines, lines, or 3D faces. We have blocks as key objects. Select all of them. These are our points that define the surface of the Earth. Now let's define the boundaries. Let's take a look at what we have. The surface of the Earth is accurate and free of extraneous objects. We can also add key points to the mesh. To do this, we will simply recreate the mesh. Select all objects including the key points and create the mesh. This surface can be passed to Surface Civil. But a civil surface can also be run as a separate command. Or we can create contour lines on our mesh. Or we can create contours from a point cloud. Or we can do 3D solid. Let's create a 3D solid. Let's see what it looks like. Select solid. Select the smooth option. This is an approximation that will smooth the surface a little, but it will look very nice and realistic in Revit. 2 repetitions. Height. Absolute or relative. If I set the height to absolute, we will get a flat second surface. If it is relative, we get 2 faces with the same shape. If a positive value is entered, the second face will be created higher than the first. If it is negative, it will be created below the first. The value determines the distance between them. We choose the absolute value, and we set the value to 792. This is below the lowest vertex of all the selected objects. Each one is a small solid. Now we are going to join them into one solid. This can be done using the AutoCAD command union, or you can do it with the union VEGA command. VEGA does it more accurately and precisely. Select objects. As you can see, we've got a nice smooth surface. If we set the value to conceptual, we can see that we have added a large number of triangles after the approximation, and that the surface is smoothed as a result. Let's look at another algorithm. We have our key points that we use to define the surface, and we don't have any 3D faces. We will now create 3D faces in a different way. We will not consider the key points when creating the triangles. Let's run the command. Let's select point cloud. We're going to make a pretty nice and dense mesh. We will set the distance between points to 1 meter and the tolerance to 30 centimeters. We're going to make sure that we accurately account for all surface variations. So if we have a slope of more than 6 degrees, between triangles we'll start to separate it until either it's less than 6 degrees or the side is less than the parameter we've set here. Let's set it to 25 centimeters. That's very good for this density of the point cloud. And we're not going to include any key points. Let's hide our point cloud. And as you can see, we've created a very dense and accurate surface of the ground that represents the relief. But unfortunately, it also represents the topography of all the cars we've seen. We'll now use the Color Mesh Point Block by Ground command. We now select both the key points we are using and the new 3D faces. The key points define our surface, and we're going to use them as a surface. And we're going to separate them into layers based on the actual level of the surface, not the absolute height. Let's set the distribution value to 50. Our new layers are now open. Layers can be controlled using AutoCAD commands. VEGA also creates layer groups containing only VEGA layers. These can also be managed using AutoCAD commands. Erase the points. We don't need them anymore. I now close the layers that contain the 3D faces that define the ground cover. In addition to the layer name, including the slope, this method makes it possible to see these 3D faces very well. It's a very accurate method. I'm selecting objects and deleting them. I erase the objects that are foreign. In this case, it's mostly cars. Let's see what we've got. And once again, we create a mesh over the objects. We select our objects. Let's set the smoothness parameter so that we get a smooth surface. Let's set 2 repetitions. Of course, if we need absolute surface accuracy, we don't need to do this. But if we need a smooth surface, we can do it this way. Look what a nice surface we have. It's almost photorealistic. Third example. We will now look at another example, creating a surface and filtering out the metal constructions that are on it. We will not be able to simply remove the constructions using cropping today because the constructions are located in the socket of the surface. Now we will use a slightly different algorithm that involves parameters that you are already familiar with. Create key points by point cloud. Let's select the surface and set the distance. We can set 4 meters of distance between the points. Tolerance, let's set 6. Range will not help us here because the object is in a socket, but we will create a height separation right away. Let it be a value of 20. Let's use the window selection method. Set the scale, 0.7. We have selected World Coordinate System. VEGA offers us to select a region. VEGA inserts points and separates them by height. Let's select wireframe. This will be more accurate to see. VEGA has created points almost everywhere that are on the surface, not on metal constructions. Let's look at this right here where we have the constructions. Let's get closer to the surface. And we see that the points are mostly positioned on the surface. There are some places for which there were simply no points on the surface of the ground in the point cloud. Let's hide point cloud. I'm going to turn off the layers one by one. It's more convenient to look at from above. I'm going to gradually turn off the layers. These are the points that are on the surface. These are already most likely the points that were found where there were holes in the point cloud underneath the metal constructions. We can remove them. This is all done fairly quickly and with complete control. I think these 2 points are redundant. These points are 2. And these points too. So gradually and very quickly, going through our layers, we remove those points that are obviously unnecessary. Now we include all the points that have not been erased and create a new surface. Let's smooth it out. And we've got a very nice surface. Let's change it to realism. Like the previous example, it looks like photorealism. We separate triangles into layers according to their height. It looks like an impressionist painting. We separate triangles into layers according to their slope angle. In this video, we told about one of the unique features of VEGA application: creation of accurate ground surfaces from point clouds cleared of foreign objects, which does not require any pre-processing of point clouds and other programs. Thank you.